Welcome back. This is the third lecture for week 1. In this lecture, we are going to talk about the course. In the last lecture, we talked about classification. We saw the different ways we can divide the game theory or different games, different classes of games that we can study in game theory. If we put all of those together, we can get this schematic. So, if game can be classified either as cooperative game or non cooperative game. Let us talk about non cooperative game first. We looked at the two criteria to decide what kind of game this is. One, we said game can be static or game can be dynamic. Another criteria we used that game can be of complete information or game can be of incomplete information. If we put both together, we can make a table, and here is a table. Here we can say static versus dynamic, and here we can say complete versus incomplete information game. So, in this box what we have is normal form game with complete information. Here in the next box we can have normal form game with incomplete information. Here we have dynamic game, or we can also call them extensive form game with complete information, and here we have extensive form game with incomplete information. Perhaps I should have had larger table so that everything could be written. So, let us understand what we are going to do in this course. We are going to learn not only about games, but on the non cooperative side, outcome is important, what is going to happen. So, we will learn the solution concept, the way we can analyze normal form game with complete information. Then we will also talk about normal form game with incomplete information. We will learn a solution concept here. We will extend that solution concept. We will improve upon that solution concept when it comes to incomplete information game. And then we are also going to talk about those game trees that we saw in the extensive form game with complete information. We won't be able to do extensive form game with incomplete information. The reason is we would run out of time. We want to emphasize on application rather than just learning more and more tools. There are many more tools in game theory, but we are going to focus only on some of them. On cooperative game side, we have already seen the focus is on coalition formation and how the payoff gets divided among them. There are two possibilities there. One possibility is that players, the participant, they make side payment to one another. So, they can transfer money, or money, better term in economics is transfer utility or transfer happiness. So, we can say transferable utility cooperative game or non-transferable utility cooperative game. We will also learn the theory of cooperative game, and we will look at some of the application of cooperative game. You should be aware that there are two instructors in this course. First 6 weeks you are going to spend with me, and later 6 weeks you are going to spend with Professor Bikramaditya Datta. So, my focus is going to be learning the concept here, the concept here, the concept here. Professor Bikramaditya Datta will talk about cooperative game and application. The way we have divided that in first 6 weeks you are going to focus more on learning tools, more on learning fundamentals, and later 6 week the focus is going to be on application. When I say that I will be focusing on tools, I don't mean to say I am not going to look at application. We will do plenty of application. In fact, the idea is to learn those tools through applying to different areas. Professor Bikramaditya Datta is mostly going to focus on application, but let us say for some application he may be talking about tools that I won't be able to cover in my part, and one such tool is cooperative game. He will talk about cooperative game and then he will talk about application. So, just to proceed further, these are the topics that we are going to cover. You know, fundamentals you will learn about game. I have put fundamental cooperative game here, although you would be learning it with Professor Bikramaditya Datta, just to give you the basic of applications that you would be doing. The matching problem is one such application where you know that you have appeared for exam, you have, or you know, a company has selected you for their Delhi, Bombay, Chennai or Calcutta office, and so those offices also have some choice that who they want to take, and you also have some choice which office you would like to join. So the matching is required there. We would like to satisfy as many participants as possible. So Bikram will be talking about matching problem. Voting is application of non-cooperative game theory. You will be learning about the outcome of voting procedures. Shapley value assigns power to different participant in cooperative setting. So Bikram will first talk about cooperative game and then he will also discuss Shapley value. Then he will get into fair division and bankruptcy problem. Fair division could be part of cooperative game, could be part of non-cooperative game, because of course when people are coming together, the value gets generated in cooperative game. How that value has to be divided, what should be the basis for that division. And then Bikram will get into what we call auction. It's one of the most important mechanism. Let me tell you what mechanism is. In game theory, in non-cooperative game theory, we see that these are the decision maker, these are the different things they can do. If they do these particular set of things, what would be the outcome? So the focus is from decision maker to outcome. Now let us say you are someone who controls the environment. Your focus is on getting some desired set of outcome. What should you do? Can you affect the effect? Can you influence the decision maker? The problem is that decision makers have mind of their own, they are rational behavior. But what you could do, you can set up the rules of interaction, how they are going to interact, and through that you can try to influence the outcome. So when we do that, we say we are doing the mechanism design. The mechanism is getting designed to get some desired outcome. So auction is one such mechanism where desired is to maximize revenue. So Bikram is going to talk about, and some of the network effects you have seen in Eco 901, the managerial economics with me. If you have not done that, no worries, Bikram will do from basic. The network effects have become very, very important in today's world. So the application of game theory you will see with network effect. Now I want to talk about the books or the material. Of course, you will be getting video material, we will be giving you lot of problems to solve, but some of you may want to look at the book. So I have listed some of the books. I will tell you their relative advantages and relative disadvantages. The Game of Strategy by Avinash Dikshit and Susan Sketh is very nice reading, very simple reading. It's a very descriptive in nature and it gives you some maths also, but it is more on the descriptive side, less on the mathematics side. So if you find the course very difficult, I recommend that you stick to Avinash Dikshit and Susan Sketh. Then there is a book which talks about not only game theory but also brings network theory along with game theory. Those chapters are also very nicely written. They are at the level of Avinash Dikshit and Susan Sketh. And other advantage is that this book is available online. If you go to author's website, you can find the complete book there. Now we are moving to third book, which is definitely more difficult than upper two book, but again very nice description, focus on application. One problem there is that I would not be following Joel Watson's sequence. I have sequence that is very different than many of these books. In terms of sequence, my description is closest to Martin Osborne's An Introduction to Game Theory, but the problem there is that book is way more mathematical than other books. So if you are mathematically inclined, you like abstract thinking, then you are going to like Martin Osborne a lot. And when Bikram will talk about the books that he likes, but one of the book that he would be following is Insight into Game Theory, an Alternative Experience by Inyagura Michael Masler, and that's by Cambridge University Press. So next question I would like to answer, how can you do well in the course? Typically what happens in most of the courses that you do, there is a set pattern that you do this, you will get the desired result. There is a linear path, there is an algorithm that exists to get the solution. The problem in game theory is that there are algorithms, but many times they don't work well. So I want you to practice, I want you to develop the habit of abstract thinking, because that is going to be your friend in game theory, and you would be able to do well if you practice, practice and practice. Having said that, from next video we will jump into studying game theory. This lecture ends the extended introduction to the course. Thank you.